Welcome to Unit 3, Polynomials. The warm-up for today was sketching a graph of a parabola. This is in vertex graphing general form with the HK of 3, -2. Remember the H value, opposite of what you'd expect. So if we have the graph, and we graph the point 3, -2. The only thing we need to look at then is this A value in terms of what that does to our graph. And where a normal parabola will go out 1 and up 1, and then out 1 and up 3 on both sides, a graph that has 2 for the A value will go out 1 and up 2 in both directions. So the next 2 points we put are going to be out 1 and up 2. Instead of just up 1. So this graph is going to be skinnier than usual because of that 2, because of that increase. The x-intercepts we have right here at 2, 0, and right here at 4, 0. That's the warm-up. Just to give you kind of a reminder, one of the things to remember is everywhere along this x-axis, if I have these points -1, 0, -2, 0, -3, 0, -4, 0, -5, 0, all along the x-axis, everywhere along here, y is going to equal 0. Big part of what we're going to be doing in the polynomials unit has to do with knowing that the y at the so I want to go over some vocabulary. Polynomial is an expression of more than 2 algebraic terms, the sum of several terms that contain different powers of the same variables. So more than 2 algebraic terms, so something like 4x to the 5th plus 3x to the 3rd minus 10x squared plus 5x minus 12. So if I have this polynomial, each of these is a term. So this first one, 4x to the 5th is a term, 3x to the 3rd is a term, -10x squared is a term, 5x, and -12. They each have different powers of the same variables. And the S on variables, that plural, occasionally we will have polynomials with more than one variable in them. But for now, we're just going to stick with one. So these all have different powers of x. So we have x to the 5th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0 if we have nothing there. And the sum means that we are adding all these different terms. When we subtract, that's the same as adding a negative number. So the sum of all these different terms. The degree, by the way, this polynomial is in standard form. We have nothing in parentheses, nothing factored. We're not in vertex form. This doesn't have a vertex, but anyway. And when you're in standard form, generally speaking, the exponents go from largest to smallest, from left to right. When we're in standard form, the degree of an individual term is the value of an exponent. So the degree of this first term, 4x to the 5th, is going to be 5. The degree of -10x squared is going to be 2. The degree of 5x is going to be 1 because of the exponent, the implied exponent of 1. The degree of the entire polynomial is its highest exponent. So this particular one is a 5th degree polynomial because that exponent is 5. This is 0. All right, the leading term is when you're in standard form again, so I don't remember what the last one was, so I'm going to make up some numbers again. Something like that. The leading term is when you're in standard form, the one with your highest exponent. So the thing to note is if these were out of order and 4x to the 5th was over here, it would still be a 5th degree because 5 is your highest exponent. The leading coefficient is simply the number that goes with your variable with the highest exponent. That's also known as our A value. So in this case, the leading coefficient is 4. All right, so given the polynomial negative 4x to the third plus 3x squared minus 8x plus 10, the degree is 3. The leading term is negative 4x to the third, and the leading coefficient is negative 4. Remember that leading coefficient, that is also known as A. So given the polynomial 2 times x plus 2 times x minus 5 squared, what is the degree? This one is a little bit trickier because this is not in standard form. This is in intercept or factored form. So this is a factor, this is a factor. So we've got 3 different factors here. And so what we would be looking at is what would happen if we multiplied everything out. We'd have x one time, and then we'd have x twice because of that exponent. So if we were to multiply this out, our leading term would be 2x to the third, our leading coefficient would be 2, and our degree would be 3 because of the exponent. So 1x from this one, and x to the second from this one. Now remember, we can't distribute this. We would have to do some pretty hefty multiplying all this out, and you can take a look at that in the notes that I've posted for this particular section on Google Classroom. But if we multiplied all this out, our leading term would be 2x to the third. So we have 3 types of roots, and these are unofficial terms. Roots is used interchangeably with x-intercepts. Both mean the same thing. Whoops, wrong thing. All right. So if I have 3 different graphs here, one of the roots would just be crossing. So if I have something like that, all it does at the x-axis is cross. Doesn't do anything weird. Another one is bounce, which means it hits the x-axis and then it turns around. So that is considered a bouncing root. And then I call this last one flat-ish because it doesn't really go flat. It only crosses in one place, but it does have this moment where it looks like it flattens out a little bit. And so that is our single x-intercept there. So we have crossing, bouncing, and flat as ways to refer to them just so that we can start to generalize some patterns. Okay, so the AA3-1 investigation, that is linked on the calendar. What you're going to be doing is using Desmos to graph the polynomials given to you. You determine the degree and the leading term, list the x-intercepts, and describe whether they bounce, cross, or go flat. And then describe the end and beginning direction. So you can talk about it in terms of y values. So something like that would be increasing to start and would continue increasing for the end direction. For some people, something like that, same idea, you can also talk about that in terms of the arrows. And in this case, the arrow is pointing down, or the arrow is pointing up. So the important thing to note in terms of keeping things straight in your own head is if you're talking about the y values, then you need to use the terms increase and decrease. If you're using the arrows, you need to use the terms down and up. If you go back and forth between those two, you're going to have a harder time seeing the patterns that we're looking for. When you sketch the graphs, and I'll do an example of this in a moment, one of the things you need to make sure to note is that I don't care how high and low things go on the y-axis. I care about what's happening at the x-axis. So this is a line from your investigation. So I'm going to pause and put the second equation here in Desmos, and then I'm going to pull that picture up. Okay, so this is the screenshot. I know it's kind of hard to see the edges of it. And I put in this polynomial, x minus 2 times x plus 5 squared, and this is what came up. So it starts pointing down, or the y values are increasing, bounces at -5, comes down, and it goes down really, really low. I left it that way on purpose. We just know that it's got to turn around there somewhere, and then it comes back up and goes through 2, and its end direction is increasing, or up. So I'm going to shrink that down a little and put it up here, and then talk about what goes in each of these boxes. So the first box, I want the degree. This one's going to be a third degree polynomial because of the x minus 2 and the x plus 5 squared. Whoops. So that's going to be third degree with a leading term of x to the third. Those two numbers should always be the same. The degree and the exponent on your leading term should always be the same. And then the next thing is the x-intercepts and whether they bounce, cross, or flat. First one is at -5, and that's a bouncing root because it hits the x-axis and turns around. The next one is at x equals 2, because it passes through it, and that's a cross, not because it passes through it, but right here, it just crosses straight through. That one just bounces. So then start and final direction, if I'm referring to the arrows, this is going down here and it's going up here. So the start direction is down, end direction is up. In other terms, we can think of that as the y values as we go from left to right, as the x values increase. I'm increasing to start, and I am increasing to end. So depending on which way, you don't have to do them both, so let me be clear about that. But pick one or the other. So you're either going to use down and up or increasing and increasing. It's up to you. But to see the patterns, you want to stick with one or the other. And then I'm going to sketch this. So as I sketch it, I'm putting on my x values at -5 and 2. I'm going to come up, bounce, turn around, and go back up. So notice there is no scale. There's no dots or hash marks along the y-axis. That's simply because we don't care about what's happening at the x or at the y-axis. Some of these graphs are going to go super duper high and super duper low, so you're going to have to zoom out a fair amount and zoom wide on Desmos to see the x-intercepts okay. But we want the basic shape of it. So that's what you're going to be doing for the remainder of this particular investigation. As you work through, try to look for patterns that you're noticing about the polynomial and the roots, the coefficients, the final direction, the degree, the start and final direction, just any patterns that you start to see. So in 3-2, we wrap up all those things that you are supposed to see. But I do recommend that you do the investigation yourself. You can start to get comfortable with some of those terms. All right, have a good day.